Hi everyone, welcome back to our channel. So today we are going to learn the transformations of star to delta, how we are going to transform. So this is a star network and this is a delta network. Rx, Ry, Rz are three elements constructed in the form of an star. Okay. So when you see it, this seems to be like an star. That's why this is called star network. We need to convert this into an delta and we need to find the values of R1, R2, R3. So this is very simple. So now I'm going to draw the conversion. Okay. So here this is the black color resistor. What I need to find out, this value is R1. So how to find the value of R1 is, okay, so how to find this R1 is, so mutual product of resistors. Okay, so just you see here, directly I'm writing the formula. I'm not using a conventional method, shortcut I'm using. So this R1 branch is connected to the red resistors. What are the two red color resistors which are connected? So that is nothing but Rx, it is connected, plus Ry, we have to write down, plus, so product of these two, which is nothing but Rx, Ry, and to this resistor which is in 90 degrees, so the resistor which is 90 degrees to this is divided by Rz. Similarly, how to find out the this branch resistor, which is nothing but R2. So you can see here, this black color resistor is this value. So how to find this R2 value is, you see this black resistor is connected to this terminal and this terminal. Okay, to this black, how many red are connected? Two red are connected. What are those values? First one, you have to write down it as R, Y plus, for the next branch, which is nothing but R, Z plus product of these two, which is nothing but R, Y, R, Z. Okay, R, Y, R, Z. So to this resistor, what is in 90 degrees? So this is nothing but Rx. Similarly, so I want to connect the next resistor. This is nothing but R3 value. So how to find this R3 value, which is nothing but this value? So R3 is equal to, this black resistor is connected between two known resistors, which are red colored one, Rx and, so this is nothing but Rx, Rx plus Rz plus product of these two, which is nothing but Rx, Rz divided by Ry. So this is how the formulas of connecting and star to delta. So very simple. The black resistor is connected between two reds. So this is one branch and this is another branch. So you have to write down Rx plus Ry plus product of these two. So to the 90%, 90 degrees, which is nothing but Rz. So to this R2 unknown. So what are the red resistor? Ry, Rz, again plus product divided by Rx. So in the gate, definitely you'll get this type of questions. So how the question will be asked in gate exam, let us have a small preview. Okay, so let us assume here, so I have a resistors like this which are connected in star. I'm labeling this as X, Y, Z. This value is 1 ohm, this value is also 1 ohm, this value is also 1 ohm. So these are the values of Rx, Ry, Rz. Okay, so now I want to you want to convert this into an delta. Okay, and I need the black color resistors. This is nothing but one, this is nothing but the second one, and I need this resistor. Okay, so no worry, due to this software issues, it is missing. So this is the value of R1, this is the value of R2, this is the value of R3. So now I'm drawing the R1 here. So this is the value of R1. So how to find R1? R1 is equal to, so what is the value of R1? So to this black, two reds are connected to which two terminal? This is one terminal, this is another terminal. So 1 plus 1 plus product of these two, 1 into 1 divided by, okay, so to this, what is to this R1, what is 90 degrees divided by 1? So 1 plus 1 plus 1, which is nothing but 3 ohm. Similarly, I will need to find out this R2 value. Okay, so this R2 value I need to find out. This R2 is connected between two reds. This is one red value and this is another red value. So this is nothing but 1 plus 1 plus product of 1 into 1 divided by, to this, what is 90 degrees connected? 1. So this is also is equal to 3 ohm. So again I need to connect one more resistor here where the labeling for this is R3. So how to find this R3 value is equal to, so to this red is connected to, sorry, this black is connected to two reds. What are those two reds? 1 plus 1 plus 1 into 1 divided by, so the 90 degrees to this branch is 1, so which is also is equal to 3. So the question what is asked in GATE exams is, if a star network of equal values are connected, those equal values are 1 1 1, red colored one, what is the equivalent resistance of delta? Okay, so you can see here, this is 1 given, this is 3 here. How many times it is multiplied? 3 times. Whenever it is converted into a delta, it forms a closed path. That's why it is multiplied how many times? 3 times. What is the resistor of each value? R, and this is scaled 3 times. So automatically each branch of delta connected will be 3R. Okay, this will be reverse in the case of an delta to star. In the case of an star to delta, this is multiplied how many times? 3R times. So this is all about how to convert a star network into delta. So just very simple. So this branch you want, black color branch you want, this nothing but Rx plus Ry plus Rx Ry divided by Rz. So that's how we have to find out. So similarly, this black is connected between Ry plus Rz plus Ry into Rz divided by Rx. So this black color resistor connected between Rx Rz plus Rx Rz divided by Ry. So this is what the formula you need to understand first, how to convert a given star connection into a delta connection. And just remember, the conversion of star to delta, if it is are equal values, then each branch resistor is how many times? 3R. Hope you had understood the video. If you feel the video is useful, please like the video, share with your friends. If you have any doubts, let me know in the comment section. And if you are watching the channel for the first time, subscribe to the channel KV Tulasiram. So this is a free channel for the development of students and faculty. Hope you are very clear about how to convert a star to delta method. Thank you for watching. Meet in the next video.